है ना सर, संजय शर्मा सर आपका होस्ट कंट्रोल्स दे दिया था।
Hello, is it okay?
यस सर, आपका स्क्रीन विजिबल है सर, आपका वॉइस भी सुन रहे हैं सर।
Okay. Now I will start again.
ओके सर।
Yeah. So welcome once again, and sorry for inconvenience. Actually, there was some problem, and as you know that we will be discussing on this AI applications in structural health monitoring, and particularly in civil engineering, that health monitoring is one of the areas which is very important, and some of the things are already in place in respect to structural health monitoring systems, but more need to be done. And health monitoring is one of the very say important say in civil engineering, because you have nowadays very bridges, you have very tall buildings, and so a lot of the infrastructure development is taking place, and that needs to be monitored continuously and regularly to avoid any mishap at any stage. And so I will try to see that that what are the general health systems basically we want to monitor, then what are the maybe from our this thing we have the instrumentation, but that data has to be converted into your to be analyzed and converted into any sort of your what are the say interferences we are going to take data, so what are the software we are going to use. And then I think we also try to need to understand what type of defects that are there, and for those defects what basically applications we need. We already have some NDT applications which I may say that this is again though they are in place, but but we also want to have some sort of a smarter sort of a arrangement while using this NDT data also. So so there also we must understand what to monitor also. That is very important. And there the basic parameters which we need to understand is the deflection, strain, rotation, the temperature, acceleration, corrosion, and any forces like pre-stressing or post-stressing, and whatever the forces which are being put on that particular building, and then what so effect is going to cause on that particular member in a building. uh, I think the best example of your health monitoring system is that aeroplane. I think there all the intelligence systems or all the informations are available sitting at one place, and you are able to see that what is happening here is that is the like the application you see that it is of from same type of application we need in our structures also. Similarly, in human body system also we are having that all the information is basically recorded at one head. So whatever the basically your blood pressure, your sugar level, your other say things are basically, if we compare with your brain, so this is again like that. We want to have our information and about what is happening in our buildings, and we need to process that information to take that necessary rehabilitation or repair measures. So so basically we may say that the process of implementing a damage reduction strategy for engineering infrastructure is referred to the structural health monitoring. And so we say question arises, why to monitor, why we want to have the information. So so basically we want to see that whether whatever the structure is, whether it is performing as expected or not. Okay. Any structure when built, it is basically for some purpose. What could change with time? ठीक है. Your environmental factors are affecting on this, है ना. So they may cause some sort of a deterioration in that structure. So we need to understand what can change with time. So is your structure is performing as expected under the conditions for which it has been designed, and how about as these facilities age and loading conditions on around them change. So that generally many times it happens that many a time says you put some additional building, you put some. We will discussing these things, sir. So that is what we need to monitor whenever these changes are happening. And so it is important to have the right information to make decisions regarding the ongoing safe and efficient operation of these facilities. And so as I was giving example in our case also in Chandigarh, there was one building which collapsed recently about 1 month back, and I just happened to visit that building one day prior to its collapse. And when we entered that, it was an old building, but renovation was being carried out, and without any sort of a thing monitoring the things. Basically, they they have not seen that okay the steel inside the column is corroded, there is a spalling, and while carrying out they further damage the columns. And we could we could suggest something. We just suggested them to okay you support the columns and around where the damage has occurred, but before any action they could take, it collapsed. So no was all inside, it happened early morning, and no was all around also. So that way basically it's, but we want to avoid those situations. That is what we want to have a health monitoring system also. So one to prevent damages, so then public safety, and then economical aspects considering the repair and retrofitting. So agar damage ho gaya to then it is a other thing. So basic aim of any structural health monitoring system is to increase the knowledge concerning the real structural behavior, what is happening under the conditions, actual conditions, to control the construction processes, to enhance maintenance activities, to increase the safety during the service, and to evaluate the structural conditions after events such as um, uh, earthquake happens, or some unexpected weather conditions, or some terrorist acts. So this health monitoring system is required in tall buildings, in bridges, in tunnels, your roads infrastructure, your say aerospace, wind energy, steel structure, etc. So everywhere we need some sort of a system. So so basically the application in this case will need that requirement is basically that okay we want to identify the performance issue, we want to identify what to monitor in that particular situation, and decide how the data will be used. So we collect the data by monitoring, and then we see that okay how that data is to be used. Then we plan and build the instrumentation for that particular data collection, and then configure data management tools, evaluate the monitoring systems, the tools, and then make the decision based. So that is a so AI applications basically wherever this is. So it is like how to gather the data, how to analyze the data, and how to use that data for our making the decision. So damage can be existing damage in the existing system. We want to know its location where damage is happening, when what kind of damage is present, then extent how severe is the damage, and then prognosis how much useful life remains once the damage has occurred. And many times you see I don't know, in this particular northern part, corrosion is a very common thing in the structures. So basically if we are unable to control the corrosion, so there I think we will not be able to know how much steel corrosion had taken place. So that means we want to estimate its how to estimate its remaining life. So basically for that purpose you require this thing. So so you can see that various methods based on your level of identification. You can say level 1, level 2, level 3. So level 1 is the determination that damage is present in the structure. Then level 2 is the determination of geometric location of the damage, then your quantification, and then prediction of the remaining service life and whether self-healing can take place or not. So for a structural health monitoring system, once you have a structure, then you have the sensors you must have some data acquisition system, you must have the data transfer and storage mechanism, then how to manage that data, and then its interpretation also is important. So basically your system identification, structural model update, structural condition assessment, and prediction of the remaining service life of the building, how structure will be done. So so that is what the same thing is shown here. I think let me go into the this thing. Okay, sorry. So you have the sensors installed at a critical or maybe at as low locations, which are basically which may have may suffer some sort of a strain, etc. Identify those locations, then have a sort of a system where you will collect the data. Those embedded sensors will be there, or sensors will be there, or embedded systems will be there. So those will be taken care of that, and then that data will be transferred to your say system where processing will take place, and that will be transferred to your this thing. So various type of optic sensors, etc., are to be installed. So you have to identify what type of sensors are to be. It may be say in-depth sensors, surface sensors, or some say they will be covered with the like cable sensors. You may have vibration sensors. You may have say strain sensors, etc. So you have to identify basically what type of a sensors where to place and how to place them, and then how to like use them. So basically you will, if you go to this thing, so those sensors will be available to you, and you can be able to install those sensors. Like you have a bridge tech, so where the so you have installed them in your column. So where you install them, location is important here. So you have all those is actuators or sensors installed in this. Even your have enforced barriers also, basically where it has installed. So where the critical location is there, that you this and identify, and then you have the local control unit, which is again the data is transferred to your main command center there also. So have your say strain gauges, or your this actuators, or your LBDTs, and whatever the things are there. So you identify them and install them there also. So so can be local, can be global techniques. Basically, local technique means assess the local character and spread, identify the this thing, and then relay the damages to actual changes in the dynamic properties of the structure. So whatever the is happening because of this thing. So so structural damage reduction is a methodology which should be used to detect damage throughout the whole structure, especially some large complicated structures. And the change of the structural model parameters are taken as a signal of every damage occurs in the structure system. So you have basically like if you like maybe afterwards we may come to this thing. So there is a one system is called the acoustic commission, acoustic this thing. So what you are doing is you are putting some sensors in the beam. If some crack or some vibration occurs, it picks up, and then that particular thing can be seen that okay, how much, if crack is there, whether it is widening also. So those things are to be monitored, and they will be done like that also. So you have to see that okay, the frequency response functions constitute important descriptors of the time invariant dynamical systems, and basically those will help us to carry out the prediction of the performance of that particular say element which we are that particular load which is there on the building, and which may basically otherwise cause damage to the structure. So yes, it is in the lab condition is it is able to you will be able to carry out, because many a times when we are carrying out any sort of a like a stress strain measurement, etc., with time, real time this thing. So there we install those say surface strain gauges, or your embedded strain gauges, etc. You may have the data acquisition system from where you get the data all that with the real time, but actually in the structure, so it is difficult, and that is required to be done also. So so basically the frequency response method is to be this thing. So it is defined as the magnitude and phase difference between input and output this thing, and from there you will carry out that thing okay, what is happening in that particular structure, what is not happening. So so you have to measure the those key elements, and what are the environmental parameters which are causing damage to the structure on a real time basis. So basically, so we that means that when we are carrying out any structural health monitoring system or AI applications will require to deduct structural damages for its safety, provide maintenance rehabilitation advice, improve design guidelines, and then in case of a disaster mitigation also, that data will be used. so so that is what you, when while operating, you have to carry out operation evaluation. So some data acquisition system is to be there. Then what data, some data may be useful, some data may not be useful, so you have to identify that thing also, what type of a data is. So that means data compression, and then you have to get select some statistical model to evaluate that particular data also. so so operation means that, okay, under which operations the structure services are being carried out, and what are the damages, life safety and economic justification for performing structural health monitoring, and limitation of your acquiring data. That means that is what many times it happens. Some data is useful, some data is not useful. Sometimes some sudden impact may cause some sort of a thing, some more say signals which may be not correct. So over the period of time, what is happening, so that is to be like identified, filtered out, and used for our evaluation purpose. So that is what. So data acquisition, when we are saying, it is a how many numbers you will get, eight sensors, 16 this thing. So that particular LVDTs you will have in that particular system, and you can install them. Then you have to see that what type of sensors are there, and then they are how they are in laboratory case. So what excitement methods you are going to use, and then what data storage techniques are going to use. So then separating the changes in sensor readings from damage to those caused by varying operational environmental conditions. So also important, because you see, we were doing one AI applications in say air quality monitoring in Chandigarh, and the period was COVID, and 1 year prior to COVID, during COVID, and after COVID. So data we got during COVID was like, it was absolutely no pollution or all that. So, but that is not a like actual data basically. It is a special conditions, special moment conditions are there. So basically, if we use that data, it may not give us as a good as a prediction for that particular purpose. So we need to understand that, okay, what is important, what is required in that case. So that is very important. So so that is what, that okay, you have to distinguish it between damaged and non-damaged parts of the building and any structure, and then select a suitable type of a statistical model to evaluate your this thing. So that is what, that okay, if you are carrying out structural monitoring, it will help you to improve the safety and functionality of the structure. It will provide you good innovative data so that you can take them into consideration while designing a building in future also. And then structural condition monitoring assessment are required for timely and cost effective maintenance also. So that is what cost saving, your autonomous damage reduction, for disaster reduction. So so this is what basically, for a successful health monitoring system, you will need require recognition of what is to be monitored, and integration of the many components in that, that identification of health and performance metric, which is a fundamental knowledge need. So what is required, whether you want to measure the crack propagation, whether you want to measure the vibration, whether you want to measure the deflection, so that is to be required. And then you see that, okay, these automated systems, they should have a promise for improving the performance of a structure with excellent benefit cost ratios. So until very recently, to a great extent even today, visual inspection by a trained person is the most common tool to identify the damage in the buildings. So if necessary, then further tests are carried out, and then we can say that, okay, find out. So that is what basically presently, so is what we are doing is this thing. But as I said that one of the applications in social health monitoring is the aerospace structures, like your airframe engines, components, composite materials, etc. In civil structure, already bridges, dams, skyscrapers, earthquake impact, etc. are being monitored for that particular system. In mechanical systems, bearing and engines are like having that AI application structure, and then human body also, you see that okay, nowadays many innovations are being taken out to detect our diseases and this and that. So there also basically is required. So we already does that. Okay, what we required, some sensors, data acquisition systems, and all that also. So anything can be monitored, like your foundations, basements, columns, beams, slabs, etc. will be done. And so why we this thing? Because during the service period of any structure, so there may be damages due to mismanagement in construction, lack of quality in control, temperature condition, damages such as surface cracks, aggregation, settlement, etc. See that okay. This type of why this cracks, how much cracks, what is the width, to what extent they are going. So, and what is happening with the passage of time, we need to see that also. So that means that okay, we need to identify what are the geometric, if some changes are taking place in the geometric boundaries, in boundary condition, in system connectivity, etc. So and then how they are impacting the structure, basically its performance is important. So sensors, okay, we need to select the sensors also. So good sensors. So what properties to be measured? Is it sensitive to that? Is insensitive to any other property that is likely to be encoded in the application and does not influence the measured property? So data acquisition systems, as I said, it may have like many channels and data also. So basically, you will have sensors or analog to digital converters and all that in will be there. So it manipulates the management of the data obtained from the center, and data transfer system are used to transfer data to system which help in predicting the failures of the structures. You get the data right, your strain, your deflection, your all those things, and maybe you plot the curves and all also, and then you can find out basically what is happening and what is not happening. So that is what basically you install the sensors there, and that signals are transferred to your this thing, and there also. So these are done in the this thing. So you have the acceleration sensor, you have the stress sensor, you have the surveillance cameras, and then so all those things are are planned well, basically at the time of installation. What are the locations where to be placed those sensors, and and then use that particular this thing, maybe your say and data acquisition system, and that system will transfer the data for your this thing. So there are so many things in your this thing. So you have to train your data, that means, and whatever data you are getting, and then you may use it like under supervised learning, unsupervised learning, and like enforcement learning. So basically there also you see that okay, how to what data is to be, whether data is genuine or the regression analysis to be done, then image qualifications classification is to be done, whether and from there you carry out the predictions and all that. So this particular machine learning, basically you make the flow chart and you see that okay, what we are this thing, so have the input, and carry out that ML model, machine learning model, and get the output, and at the end of this thing see that okay, which is giving you true prediction, as I gave an example of this air pollution during COVID and after COVID. So whatever the false things you say that okay, it is not, that is to be uh, omitted, and then finally you get your system and get the data for your evaluation purposes. So that is what you need to know the data. You need to clean the data, and you need to augment the data sometimes also. So that is what you use some models or some maybe statistics to carry out averages, medians, and data visualization, and then use this record. Then you see that okay, how to uh, what data is to be omitted, what data is to be used, and finally you if some additional information is required, so you do that also, and finally carry out your this particular thing. So machine learning or algorithm, maybe regression, maybe regression, maybe clustering of that particular data into one system. You have to make the decision trees, you have to make the neural networks, you have to assemble the methods, and then supervise your machine, etc. For all those things are to be decided when you are say putting that data by using some sort of software also. So all those things are to be, you have to understand that, okay, what logarithm is this, what is the this thing, and then some in like your in this ANN model you will get lot of layers. So again, which layer is important for your output and which layer is to be omitted, so all those things, and what are the hidden layers. So you have to understand the software you, and then apply that particular thing also. So there it is important how to train that data to be used for a particular analysis. So again, you understand that thing, and then layers, and whatever the layers are same thing. If it is a crack, so what cracks, what are the conditions, what are your so naps, and then you see that, okay, you are carrying out this thing, and then finally you are deciding which one is the useful one. So omission, and using that particular thing into your carry out the various like analysis, regression, or whatever you are carrying out this thing, that also using any sort of a software, and then find out whether crack is significant or crack is not significant, whether it is causing further damage or not. So that data is to be used for that purpose. You can use say many logarithms, as I said, okay, uh, for different stories, for dams, for so so input, what input is required. I have just given a sort of this thing. I would say I have not used everything. I have just collected this particular I think from the literature and just tried to present it here. So so for different, but the purpose of this slide is, okay, you try to see that for your different this thing, what is the logarithm you are going to use, and what is the output you are going to get is becomes important here also. So logarithm may be a neural network, it may be some other this thing. So all the things like for different things you try to see and predict the things, okay. Like in that particular thing, basically you wanted to find out what is the deflection variation, it is a bridge. Then then use like what I mean to say, use your modeling, use your techniques, use your like whatever the method you are going to select, and from that basically predict basically what output you are going to get. So that you analyze it further this thing. So this is again picture showing sensors, and this is the model basically for this thing in the different stories, like earthquake effect used to be studied and all that, for your bridges and all that also. So I will just skip this thing because I'm just giving you this thing that, okay, what type of a system you can install, and you can find out to determine various stages of a structure and all that also. So so then once you collect data, you diagnose that particular data by your these things, and and finally you see that, okay, what are from based on that particular thing you decide your further repair and maintenance of that particular thing, or whether it requires strengthening, or whether it can be, it requires reconstruction or this thing. So maybe different this. So maybe even some moisture or dampness is there. For that purpose also you can install certain sort of things, and and then based on that you will, you got to decide your remedial ways. Like if the dampness is there, so okay, you cause what damage is causing, then you how to carry out the repair method, and select that. But all those things can also be used in that particular your structure health monitoring. And then so that is what your health monitoring will give you, that understanding of a behavior of the structure. It will help you do early damage detection. It will give the assurance of structure strength and serviceability. Then decrease downtime for inspection and repair. You don't have to go manually every time there, and this thing, and it is very difficult to if a long bridge is there, if a tall building is there, not possible basically. Like you are this thing, and then start this thing. So but then it is important, like what to monitor, how to monitor, why to monitor any structure, or any this thing. So in many times you have a like the service life is assumed to be 80 to 100 years, but how many times? Because there's sometimes many type of a deficiency in construction, and the quality of construction is poor, your service loads during that, then you may add or you may put some other additional uh, stories on that particular building. Sometimes you have structural deficiencies, so we need to find out basically. So it is all those things. Okay, we identified the things there also and see that okay, what can be, and then what is happening to this particular structure. So we need to, and nowadays I think now it is getting mandatory to get the your this stability certificate also for the building. And as per your this thing, and I don't know, even AICT and all the, even Chandigarh, you have the all the CBSE affiliated schools are to put sort of a structure stability, get a structure stability certificate. And what we are doing nowadays is, because they don't have old buildings, they don't have that sort of a like system where some institute systems are installed to monitor the behaviors of structure. So we do non-circuit testing there. Go there, see the non-circuit testing, and we carry out the present strength. And then it is again very difficult whether to assess the building as per the present code, because your many buildings in the that particular zoning has changed. And earlier there were 5 zones, and now there are 4 zones, and one is not there. And so all those things, buildings, old buildings are to be required to be say retrofitted. So how to, whether to give, how to give, so it is like this thing. But if we have some sort of a applications where we can get the data, analyze it, and then use it, that particular this thing, for prediction of the system. And then it is very important for any say health monitoring system. So if anything happens, so well in advance some action is taken, so it will not only reduce the cost of repair also, but at the same time it may cause prevent the damage to the property, and also some life losses or human life losses, etc., later on also. So timely action is important. For timely action, your AI applications for in this particular thing is very very important. So that when we say carry out any like your say structure stability thing or like that also, so we need plans, we need geotechnical investigation reports, we need foundation details, and many times, and what are the design at present also, and we don't have the data available to us. So even few years back, we had one like in Chandigarh, we did consultancy to Miss MC Chandigarh. So they were having a building which was constructed so it was having basement and 1 story, but it was designed for like maybe 7 stories, 6 stories, and they were not having any data, any drawings, any this thing. And another thing was, it was basement was underwater, so no systems to basically detect whether corrosion has, it is causing corrosion or some other thing. So yes, we use the NDT methods, but then NDT methods are again like you are taking data at few locations. So how to use that data? If we are able to like do some sort of a work where we can use that entity data for say and apply it to like throughout to every part of a structure, so then that may be more useful. So I think some work can be done. Okay, how to utilize that? One thing is, okay, like in situ monitoring is well and good if it is available, but how even your how to use your entity, I think you all understand how to use entity for that particular purpose is also very very important. So we don't have any things available, we are doing a lot of many times facing this thing. And there are different type of structures available this thing. And many times we find that okay, they have changed the loading conditions also. We were designed for some red dot, but they have put some additional load in between also. And what, how it is causing, some false ceiling has been instructed, some platform have been, additional rooms have been generated. Then sometimes design assumptions are different, and what are the actual conditions at the site are different. We need to understand also. So different sign condition, different sort of a thing. When many times this the additional like flooring is put, or additional site conditions are changed. So and they are all causing basically some this thing. So you need to measure basically whether like your this additional flooring is able to do that or not that. This is one particular building in, but these, so they have put these tanks on that. They were not, the roof was not designed for this thing, so they have put the additional tanks here. And those, particularly when they have installed and put these tanks here, so it caused severe damage to the this beams and slab in that particular this thing. And no doubt we use only NDT techniques, but yes, had there been some existing monitoring system or this thing, so that could have saved it. So this is again many things, this is just showing that okay, how we change our like conditions at the structure. And this is again a very common sort of a thing. Many times people do that. Many addition alternations are carried out many times. And one particular wall has been built and a duct removing. So all those things and a hole in the column, wrong installations, addition, alterations, etc. are there. So you see that okay, I'm just showing you these things that many one member has been removed to create this opening. But then if we have some mechanism to have a in situ structural health monitoring system and then use that system for our analysis, etc., so it will be helpful. So it will stop the damage and stop the complete collapse of the structure basically there also. So, and then we and data, how can be generated that data? I think one is the visual inspection, which we are saying that by carrying out this thing, and this is the diffraction. So we have to see that okay, then pattern of the cracks is very so observe. So how to, what type of a cracks are there, what is the pattern of the crack, whether crack is this thing. So you see that okay, go there and see visual inspection. And and this is what basically you have to gather the data and use that data, put in particular your say machine learning and all that, and then you predict the behavior of the structure using that particular data. So this is the pattern of the crack. You can see where shear, whether fracture crack, because your repair rehabilitation measures will depending upon what type of cracks are basically appearing in the. And I always say that in any particular building, this thing, uh, the first visual like your say indication is the appearance of the crack, like your temperature in the body. So if you are having a high fever, you are having a fever, it is maybe corona, it may be flu, it may be some viral infection. So we have to see that okay, so for that I think you need to further test. But yes, the first symptom like your body temperature is the in building, it is the appearance of the crack. So basically what type of a crack is there, for that further you need to identify this thing. And if you are able to do that also, by using some sort of a this thing, so flexure crack in a beam, columns, tension cracks in the column. So from the pattern of the cracks, there is a compression cracks in a column, this is the settlement cracks, actual building. So all this data is required in your health monitoring and all that also. And you see that this is generally what happens many times. This is the earthquake, cracks due to earthquake and all that also. So so settlement again. Corrosion cracks. Corrosion is one of the, as I said, is one of the major things. So corrosion again is of two types. One is due to the carbonation, other is due to the presence of chloride. So again that their pattern is different. So so we need to find out by visual inspection or maybe some other methods by your this thing AI applications, or maybe your installed sensor, etc. So we need to do that. But any case, this is I am just going further. We have already discussed that okay, what the AI applications are there in structural health monitoring, and but for that understanding of what type of a data will be required is required to be generated. So we are giving, I am presenting you this particular like type of a defects which may occur in any structure or in any are there, and those we then we have to plan our thing to monitor the that particular site of defect by our AI application. Here we are doing visually, but yes, we have to generate some of this data. In any case, you have to acquire, maybe using visiting site, maybe using entity data, maybe using installed this thing and that data, and then use that to predict the further behavior or future behavior, basically. So that future, this is a very common sort of a thing. That was, if your crack is along the bar, then it is a carbonation failure. If it is like this situation, like this, and isolated, or maybe this thing, it is a chloride ingress, corrosion due to the chlorides present into the cement, or maybe water also there also. So that is what is happening. So corrosion cracks are to be monitored, and this is a very common site, particularly in our part. I am don't know the Andhra side, but or maybe other side also. But overall, these things are very common. And then this is just showing that, okay, lifting stress cracks, maybe it is very common nowadays, where we are using that particular prefabricated members and all that also. So corrosion in a steel structures, again, it is a very important. So basically, we need to know where to monitor, what type of testing, where to look into that, where to install our system. So that is very important. And you see that this is one visual inspection. Okay. I am just showing you this thing that, okay, the this type of a things are there in the structure, in any sort of a building, in any sort of a this thing. And like dampness again causing the corrosion in your this thing. So again, totally damaged, ऊपर का जो है, it is this thing. So sports are not this thing, and many this thing. So many changes are made, and then those changes are causing sort of a this thing. So what to look, what to think, important. Storage is there, one of leakage from the rooftop is there. So है ना, column done in a different this thing, है ना, concreting and all that also. The concrete is not proper, है ना. This is one column offset. So again, it will cause the stresses, or maybe centricity we will put up in that particular this thing, and then how it is affecting the structure, which is again important. This is again the same thing. And this is the cold joint while at the construction. So all those things are there, which are there and which are to be monitored, which are to be done. Doubtful concrete, ceilings are like that. Okay. Shape of the structure, many types of things are there when we go actually to this thing. And there it becomes important that, okay, we carry out the structural audit, and that for that structural auditing we may require this particular data. And that may be your AI applications, or how you can use that will require your some sort of a this thing. And then you can use, this is the visual inspection, then you can use your NDT tools also to get the data for your this thing. One thing is, okay, because what you can monitor the propagation of sensors. You can amend them, and you can monitor whether some vibration are caused, or they are causing sort of a cracks, etc. That can be done. But then at site particularly you have to go. So even NDT is a smart application. You can make those NDT very smart. And nowadays you have like many of the applications which are there in this thing. The present day data is basically, okay, we generally depend upon the cube strength, but again, sometimes cube strength may also be wrong, because it depends on so many factors of this thing: your size of the cube, shape, mold material, compaction, curing temperature, etc. And that may not be proper. So we can use the NDT also for this particular health monitoring. And that particular health monitoring will be, so a lot of things are there. So we can go for it. It can help us in quality control also. It can help us in carrying out evaluation of the structure, estimating the compressive strength of the concrete, identification. So all this data is needed basically when we are going to predict any sort of a, we're going to use the machine learning, etc. So we will require this data, and that data can be generated through your visual inspection, through your NDT applications, etc. So that is what you do that. You need to know the enforcement details also. You need, depending upon that, okay, uh, we can use the different type of entity techniques in our structures also. And I'm not going into detail, sometimes case study, something thing. Let us just go through this thing. That are the say various type of methods. Like you have a uh, in the entity, you have basically the methods which are able to use the surface hardness methods, dynamic or vibration methods, and under this you have like your uh, uh, a remote hammer is the one particular which is used on the surface. Basically, it determines it measures the hardness of the surface, and that hardness of the surface has been correlated with the strength. So these are the two methods. Then vibration methods, you measure, you use some sort of a pulses in that particular, and that you throw into your system, maybe some vibrations or maybe some ultras, like your waves, etc. And depending upon those waves, you measure certain properties. One of the few applications. Then magnetic methods, we have the enforcement detectors and cover meters. And electrical method, you have the dielectric system. Then basically we are using for this thing, or let me go through that. You have that radiography methods, not very commonly used. Then partial discrete test. So, and then chemical test also, you may carry out like colloid carbonation test, alkalinity test, and a crack measurement, etc. is done for this purpose system. So here, so what are the parameters you need to measure is compressive strength. For that, the different say tools available to us are the remote hammer, Windsor probe, ultrasonic pulse velocity, core, Capco, pull-out, and any of the combined methods together. For fluctual strengths, we have the break-off test. Direct tensile strength, we have the pull-off test. Concrete quality, homogeneity, you can use this ultrasonic pulse velocity, pulse echo, endoscopy, gamma ray, damages, and due to the earthquake, etc. We can use Ramon hammer, ultrasonic pulse velocity, caustic emission, etc. Crack, we can use ultrasonic pulse velocity. Then a pile integrity, we can use this pile integrated pulse echo test also. Steel, for we have a performator or half cell potentiometer which can be used for this thing. Corrosion, and a bar locator is a performator, and a corrosion we can use this resistivity, half cell polarization, carbon share, chloride content, etc. And once we are using this stability analysis in order also, and we are using all those methods in checking the stability of any structure also. So this is the Ramon hammer. It is a very simple method, but if we do data we obtain from this is the Raymond number, and that Raymond number has been converted, is again a prediction, or we can make and the prediction by Raymond number for strength estimation is in the range of plus minus 25%, which is a huge range. But at the same time, if you do the cube also, it also says the cube, while this thing CTM, it gives you plus minus 15%, so 10% difference. But yes, can we make these prediction more like this thing? Because here what we get is uh, some high rebound numbers, some low rebound numbers, depending upon where the rebound hammer is hit. And then through AI model, etc., if we put that data, so here also, can we make some sort of a machine learning to predict the strength of say concrete or member uh, through remote hammer, which give you higher accuracy. So that is the challenge here. So data we can obtain by using this remote hammer, but then so that is what, because this remote hammer is giving is depend upon so many factors. So these all factors are to be taken into account. So can my AI model can take care of these factors, whether it's size, age, moisture conditions, aggregate used, and a type of cement used, carbonation, etc. Nowadays, I think whatever the Ramon hammers are there, that carbonation check is there in that particular. So you can make the carbonation corrections in that particular thing. But yes, so many parameters are there. So we have to understand what are the parameters which is affecting our final results, and how to, in by using some AI model, whether we can use. No doubt in Ramon Hammer, I think what we do is we have a standard ready to use graph. We, we get the Ramon value, we study that Ramon value against that Ramon number like this. Okay, this is not okay. This is there. This is one type of this thing. So this has been made more like simple. Is okay. You get the reading on this scale, but here it is a microprocessor based. Okay, you can say it is a some sort of intelligent sort of a system which is basically getting. You can, in this particular system you can fix that how many values are to be taken on average, how many values are to be reduced, है ना? Like higher two values, lower two values, average of 6, average of 8 values, that you can basically feed in that particular thing, so that you can see that okay, what data I require for my intelligent prediction. Say, so this is I think I am not going into this thing much of the this thing. Okay, how it is to be used, what is to be used. Let us not go into that. But but yes, these values we must take care of this thing. Impact direction, what is how many mean values and all that also. So as I said, the prediction is about plus minus 25%, but we can make that particular prediction more accurate if we are able to understand the data properly. So here I think a very simple thing we are using is for prediction of quality of the concrete or strength, etc. is there. So this is what basically strength I say. This is the generally ready to use graph. So but if we are have a AI model, we can reduce further our whatever the say discrepancy may be there by using this particular graph. But Sana, health online monitoring is different. But yes, we may not depend upon one simple thing. We have to use these entity methods for that. So there are different type of hammers I have shown here. This is the low strength hammer. This is a hammer for high strength concrete or mass concreting. Okay, the different type of hammers. So simple method, but then accuracy is to be improved, data is to be used. This is another surface hardness method, in which what we do is we fire these bullets through this gun and fix it on this surface, and then when we fire it, it will penetrate depending on the hardness of the surface. Same value, that is what we say, hardness of the surface. So this is again prediction is at plus minus 20%. This is again a very commonly used method for getting the data in our concrete structure nowadays. This is what is called the ultrasonic pulse velocity. So because in the Mount Hammer we are getting only the surface value. Here, if we use ultrasonic pulse velocity, you are seeing that what is inside the structure also. So this is a direct, semi-direct. It can be used in different, because it is sending the waves through this transmitter in all the direction. Those waves are picked up, and these waves cannot travel in the void or in the air. And when if there is a void or air, so they will take a longer path. So time taken to travel from this end to this end is noted, and then you can see what is the velocity, and that velocity has been correlated with the quality of the concrete and maybe strength also. So that is what the old, and nowadays we have a new graph 516. So so it tells you what is the concrete quality. So UPV value is there. So I'm seeing the time also. Okay, and the ultrasonic pulse velocity can be is a very this thing good method, and you can determine the depth of the crack also by using this thing, particular this thing. So again, so again, it is a near to vertical crack can be, its depth can be determined, like here, this I am showing here. This is the crack. So it is almost a vertical thing. Yes, we can measure it, but then horizontally or inclined crack. So there also, I think if we are able to use that particular data and convert them into some sort of a like machine learning, so we can use this particular data in a better way. I think because AI applications are going to be there in every this thing, so we have to find out further improve our systems, whether we can make these systems more intelligent. So that is also one thing. So same thing actually I have shown in a different this thing, that is the instrument part, and probes are there. Those probes measure the one probe sends the UPV waves, other probe receives, and time taken is noted here. So this is the, you can feed it into this particular system. How much is the distance? So and then once you send this thing, so it will tell you the velocity. And this is remote number also can be feeded here, and it will give you the strength. So both are correlated in this particular this thing. But and then this is one of the things. So so that is what you can get the concrete quality in this also. So you get the data, and that data is to be like properly used. So for that you have to, if you are, you can plan some sort of a like machine learning systems for this particular system, so they will be, this data can be more useful. However, for our purposes nowadays we are using this particular data only for like you're getting the concrete quality and correlating and using remote hammer and correlating the both the things together. But you can determine this as a crack propagation and a UPV value along that. And then it is also telling you, if you are using both hammer and this thing together, so it is telling you, okay, high value, high impact, no corrosion, medium range UPV. Because many times it happens that, okay, we have this thing, because of the carbonation we are getting high remote number, but when we are using carbonation means that, okay, there is some debonding between concrete and this your reinforcing bars, and those are giving the low values. Many times we get, many times it happens also, that also we have to see that, okay, how you to utilize this particular data also. So here also there are many factors which can affect the say ultimately your time of travel, and that we must try to see, okay, how it can be this thing. And then this is another test which is again pull-out test, which we call the capco test also. So basically what we do here is again a sort of a in situ system in which we apply a force to pull out a some pull out the concrete from that particular. So what we do is we have a disk attached there. So we, this disk is fixed in this particular system, then it is placed on this, and with the help of this we pull it up, and that force to pull it up is basically is recorded here, and that is correlated with the this thing. So this is a somewhat better method as compared to remote hammer, and so so it is a more dependable method. Basically, that is what your results. So that is what your prediction of data. Your this thing, how to make the things more smart, more this thing. So that is required to be done. This is again a pull-off test. Basically, yes, in the laboratory we need to we carry out the pull-off test. Basically, which made the institutional size strength also. So almost same method. Okay, you fix a disk here, and that disk is again pulled out with the this type of instrument, and if it is a bond failure, so it will fail at the bond. If it is a concrete lesser strength, so it will fail at the thing, but you will able to find out what is the tensile strength also. So here the even pull-off test is there, which is again where determining the flexure strength. So we have with us this pull-out test and the capco test, but not the pull-off test basically, but it's very similar to your this thing where you can determine the flexure strength of this. Kind of core, you understand that, okay, taking cores again, then again you can once you have to see that, okay, what is happening to your cores, and also with the passage of time, and you can find out cores, and you can use these cores to find out carbonation, you find out strength also for this particular system. So you have this particular sample for that purpose. So it has, then another type of a instrument is the this is that called is the ultrasonic thermography. So it measures the thickness. It is again almost similar to UPV, but here, because in that you have the two probes, sometimes your other face is not available, like in slabs or maybe tunnels or something like that. So there you use this particular ultrasonic thermography, This is something like that. So this method on saying step wave method, pulse and propagation of the waves, etc. is there. This is what the instrument. So how it works? It is a one-sided. It has got lot of number of probes here. You can say it is sending the waves, receiving the waves, sending the waves, receiving the waves. And so going down deep, fine. You will be able to the basically what is this thing. But if the wave is coming some from this thing, so here you will find out. So you can pinpoint any sort of a delamination, any sort of a crack by using this, or maybe thickness, at what depth the delineation is occurs. So that particular things can be found. So you get this type of scans, and their scans you interpret and use them for your this thing. So this is again a very few like in India, not done much, but just but very useful test for your this thing. The carbonation is again a chemical test, and you can you I think again I will say that this particular depth is important. So once you get this that and then correlation between these all parameters, you may see you can have a some sort of AI model where you can see you put the remote hammer test, you put the your all the flexure strength and all that also, you pull off test and all that. So make a sort of a like some sort of a equation where you can put this data and you can use that data to predict what is happening in the structure. So corrosion is again one of the important factors. So corrosion also data you generate through your this half cell potentiometer, where where you use the voltage. Basically, you throw the current, and that particular current is basically depending upon that corrosion and this thing. So it flows into that this thing, and then it measures the voltage, and that voltage has been correlated with the corrosion activity in the structure. This is what so give the potential or your this thing. This is what is called the copper separation. So you find out the what is the probability of the corrosion. So this is the again I will say the indirect application but smart application for that purpose this thing. So here the type of instrument is there. This is the half cell potentiometer. You put the copper sulfate solution in that and and that particular this thing is again connected to your like uh, mm, display unit is there, and make the surface conducting and expose the wire, put one end to the wire, put one end to the concrete surface and measure these readings, and it will tell you how much is this thing. Because resistivity meter is another method. Basically here what you either you don't need to expose the concrete. So here it is measuring the resistance to travel to the current flow, and that is again correlated with your uh, corrosion into this thing, corrosion risk, because corrosion is one of the major thing. A lot of work need to be done, and corrosion happens in any structure many times. I say collapse is sudden. If it is a chloride corrosion, collapse is sudden. Corrosion due to carbonation gives you some indication, but not otherwise this thing. Okay? So this is a resistivity meter. Again, it is to be used and to be in that way. Okay. I am not showing, I am just telling you that how to generate the data. This is the impact echo. Piles are there. So for the piles, this thing you have to find out. So what you do is you, with the help of this hammer, you send the vibrations. The vibrations travel down into the pile. Here you have a already software available. So you know what is the depth. So this is what system. So piles, hammer goes down. If there is any imperfection, any crack, so they will not travel down. So at least you will able to know any sort of this thing. So if I have 50 piles, you can test with this method 50 piles in a one day and find out how many piles are fully penetrated or are working fully or they are not working. Well, some bulb is there, whether that bulb is okay or not, that you can find out by using this test method. Because load testing, if you do on every pile, it is very difficult. So you will able to decide by using this particular method also. This is again a very good method where you are, this is what hammer sends the vibration, and those vibrations are picked up and finally interpreted and you get the prediction. So this is what again scan you get, the graph you get, like your ECG. So if it is a good, smooth, fine. But if there are imperfections, sine wave is going on. So you can say, okay, at particular depth, there is some sort of a problem in that pipe. So this is what you can predict using these sort of things. This is again a cross-talk longing while integrity test. This is a basically give you the scan also. So these scans will at what depth basically it is a much accurate as per pile integrator. The cross or logging method is much is better than the pile integrity test. Pile integrity test is only giving you where something happened, but it is giving you how much and what is giving you better data and better this. So then GPR systems are there in our system. So those systems can also be used to find out the like any type of a disinfection, any type of pipeline in your this thing. So that can be any metal below the road or in the slab or in the concrete. So this can be used for that particular GPR systems. Or again, you get this type of scans there, and those scans are to be interpreted by your this thing. So data, you can get many of those things. You can get the rods, you can get even this type of way. And so bed scans. So different type of systems are available to us for which for predicting the different things in the structure. But then that data is available. Data you can use them, but data is to be trained basically using some sort of a software, some sort of a modeling technique, so that you can give it better. So here, what I have covered is your this what is the health monitoring, why do you require the data, and then how to generate the data using visual inspection and your NDT techniques. Again, this is a infrared. This here also we have used this particular infrared camera to evaluate a timber structure, very old timber structure in Himachal Pradesh. It was a governor's house. It was constructed in 1853, all wooden. So they have a like base of this masonry, stone masonry, and on that they have put the horizontal wooden member and then vertical wooden member screwed to that and cross members, and in between they have again filled up your data, your this thing with that stone masonry also. But with the passage of time, the timber got affected because of the water seepage, etc. So it was so we were to predict where the timber is affected and where the timber is not affected. So what we say measured is the using this camera temperature. This thermal camera gives you the temperature. So high temperature means okay, but low temperature means there is a moisture. So identified those area where the moisture was there, and then identified the members also. So which requires the replacement using this infrared thermal camera. So this is what basically it gives you the temperature, even temperature pattern like you use in the COVID and all that also. So that particular thing was used. So we can use it this thermal camera to get the data for thermal heat loss, moisture contamination, and a concrete integrated production, locate missing or damaged insulation, identify air leakages, thermal performance. Even nowadays you want to measure the U value also. You can use this particular thing because in green buildings this particular thing is required to be determined. So that is what I say. You get the temperature, you get the color. So here we identified the areas with low temperature, with with moisture. So means temperature is there, that means moisture is there. So basically that particular thing was used to find out that this is what your tank damage. So different color pattern will show you the different things. This is the crack, very common thing. Endoscopy, you put the camera because hidden parts are there. So there, how to get this endoscopy, you use this particular thing to get the data. So underwater inspection can be done. Then vibration all to be measured. So put the vibrators around that particular building and find out what is happening and how this thing is a moisture meter. Again, we use this moisture meter and thermal camera for predicting that timber building. Yes. Radiography is again, but not very commonly used. It is in the lab only, where you can use this and the water permeation, and this test can also utilize for this. This is one in situ monitoring of concrete development. Like it is called the commometer, and what it does is it measures the temperature of the fresh concrete. Because of the heat temperature is generated, that temperature is measured, and that temperature is correlated with the strength development here also. So that is what is called the commometer. So different uses different equipments are there, how to get the data from this particular, then further you have to make some sort of a model, AI model to predict this data for your future predictions. That is what this is a carbonation test. So it is very important because it gives you the pH value is important in a, because pH value lowers down because of the carbonation. Carbonation is basically carbon dioxide, CO plus water ingress converts uh, into a carbonic acid, and that because of the carbonic acid your pH of the concrete goes down and it causes the corrosion in that particular structure. So again, chloride content is again very important there. So here you have to see that, okay, what are the number of tests are required: standard course 3, the bond hammer 12, what are the porosity 2 in what particular element. So and then this is very similar to your like your medical science entity, this thing. So more medical science is like have some but little bit more developed, but here again we can compare our orthopedic doctor, structural engineer, pathologist, your entity consultant, surgeon is your structure rehabilitation, construction medicine is your construction chemicals, stethoscope is your bone hammer, sonography your UPV, biopsy your core cutting, and then you are now jacketing also by plaster, etc. So all those things can be this thing. So so there are many technologies are available to us, but then this are is required to be further AI more to be made more intelligent systems by using this AI applications into our structural health monitoring system. So we have this like data gathered through your visual inspection, through your entity applications, and then then you carry out analysis of that data, use that data for your future prediction so that you can plan your repair and rehabilitation well in advance. So with this, I come to end of my presentation. So anything from your side or any questions or any like this thing, you are most welcome.
Thank you. Thank you for the wonderful session, sir. I request participants, do you have any queries? You can ask in the chat box or you can directly ask with the sir.
Have anyone of used somebody is working in the area of structural health monitoring?
Hello, sir.
Yeah.
Can I know any specific sensors are used for the to evaluate the pressure in the grid, sir? Water pipelines
For what purpose?
to measure the pressure and all other properties of the flow, sir.
Water you have basically nowadays all the like if systems there, even you can sitting out this thing you have like you have installed your sensors there at the different locations, and those sensor data is transferred and you're sitting at your system. You can find out your like what is the pressure, where pressure drop is taking place. These systems are already in place basically.
Okay. And can I know the name of the sensor, sir? Piezo sensor or so many sensors are there.
That basically okay. If you are using in the dams, is the piezo sensors, or then the embedded these systems are there in case of your other this thing, and data can be generated through any system. You need to some sort of a like data transfer cable, and that data is to be transferred basically. Any sort of a system, piezometers, any sort of a thing can be utilized. First thing is okay, you are utilizing, you are measuring that particular pressure or whatever, then that particular pressure through your embedded system is being transferred to your like where you are getting the data this thing. So data acquisition system.
Thank you, sir.
Yeah.
So good evening, sir.
Yeah. Good evening.
Thank you for the like informative presentation. I just wanted to know like the difference between resistivity meter and half cell potentiometer. Both gives the corrosion. Then
Yeah. Actually, yes. This is again, half cell is working on the principle of voltage measurement, because current is passed, and how much, like for passing that current, how much voltage is being utilized. So half cell potential meter is measuring the voltage, whereas resistivity, we are measuring the resistance to flow through the current. In application point of view, the half cell potential meter is basically, what we do is we have to connect one end to the bar, and that means you have to expose the enforcing bar and other end to the concrete surface, which has to be made conducting by putting that basically that it makes the half cell, basically that is why it's called the half cell potential meter. You are ready. Whereas in case of resistivity meter, it is just throwing that current inside the thing, depending upon the corrosion in that particular in the enforcing bar, there is resistance to flow to the current. So that current is that is measured, that resistance is measured in ohms, and indirectly, basically, what is the value you are getting, either voltage or either you are in the resistance, that is correlated with the corrosion development in reinforcing bars. So basically both are measuring the corrosion, but it is as I find, we have used resistivity meter as say half cell potential meter, but resistivity meter is more much better or easy to operate as compared to the half cell potential meter.
Sir, if I wanted to do, why? Because we even do some of the structural audits here. I am from
Yeah,
Maharashtra.
yeah.
But I just got a were there. The bridges, the piers were
Hmm.
constructed with the help of stone mason.
Hmm. Hmm. Yeah.
So what should come with, what test can do it like to NT?
Your voice is breaking, but actually stone masonry, you will have to
Hello.
carry out the visual inspection. You
Yes,
have to
sir.
carry out.
We have did visual inspection. We have did.
Yeah.
The bridge was like at least 75 to 80 years old. So we
Yeah.
did cement over there. It was purely constructed with lime. And
Yes.
through visual inspection, we have given carbon test. We have conducted the decks which were available. We have conducted UPV. Even we have did core cutting, like core cutter. We have used. So these all
Yeah.
conducted, but there the doubt was again like if you go with like cement mortar or even if you go with brick masonry,
Mhm.
should we have any instrument specific to that?
Not in my knowledge, because for stone masonry and for brick masonry, you don't have any sort of specific equipment. We have used, no doubt, this like P-type rebound hammer, but that may not be there. But okay, you can repair, etc. Yes, we carried out with some, we suggested some repair in that Kalka and this Shimla region, which was again like very old structures, piers, etc. were there. So we just suggested them, by visual inspection carried out some, let's say, joints were breakdown, and we just suggested them to high pressure with high bond strength one that was there. So through that, basically we asked them to strengthen the thing, so they carried out and it worked. So actually, yes, marrying sort of a thing by using. They also wanted this railway people to us to do some sort of a testing there, but then again there was nothing was available with us also. So we just depended on our this visual inspection, and based on visual inspection we carried out the rehabilitation.
Sir, again, one instrument like as you said, the core cutter and pull out. I find like both were the gives the same
Yes, yes.
experimentation.
Core cutter, but Capco is the one instrument which is not damaging much to the structure, and it's like application wise is strength like this thing, because core you cannot take. Okay, core generally what we do is we do for calibration, then we use the remote hammer at most of the locations. If it is a very critical, then okay, fine, that depends upon location to location, site to site, also site condition also. But Capco is the better sort of a thing, because damage is up to 50 only. No doubt the cost of conducting the test is very high, because we have, once you fix that particular dolly, what we call is into the system, fix it, and it has some sort of a special ring. Cost of a ring is about 3,000. So it cost is very high. Generally, we charge about 7 to 8,000 per like your this thing. But yes, we have, and we have carried out, and the results are almost comparable, much better. Even core is also, sometimes you see core, once you take it, is a localized damage, so core may not give you always the correct strength, but Capco is more reliable, I will say, as compared to core.
Sir,
Yeah.
sorry, can you just share the details, like where we can purchase this equipment, or can you share this PPT through the coordinators, so that which will be much helpful for us and in future also, I think. Why? Because I even joined most of the courses from NITTR
Okay. Okay.
to have good experience from these people.
Yeah. Yeah.
So that's the reason, like if I get a good contact from there, I can even do it. Sir,
No.
last question from my end. Like what do you recommend if I get a structural audit for a building, the basic experiments which I have to perform?
Actually, yes, structure, again, I here also the question is, we need to understand is, as per according to me, my understanding, there is a structure audit is you are carrying out for what purpose? Basic things, yes, I will say that is a condition assessment you are talking about through using NDT. But structure audit means, okay, you also model the things, use that data to carry out analysis, and design data also you want this thing, and then you find out the like whatever the basically difference is there. But condition assessment means, okay, deterioration has taken place, you want to know the present strength, you want to know the say corrosion, this thing. So basically, for your strength, you use this, mostly we are using this remote hammer and UPV, both tests we do. Okay. Corrosion, we are, again, we do this your uh, this half cell potential meter, or maybe corrosion this potential meter test, or maybe your resistivity meter. Then carbonation is to be done. Then you carry out the chemical analysis, chlorides ingress, and your this also uh, maybe sulfate also. Then your once you have carried out your, sometimes you may require some cores also, many times, depending upon, because if you are taking, having a say pier of a bridge, nowadays it is a very closely this thing, so you may not be able to carry out the core basically, so that Capco also is recommended. So basically, you need to carry out strength test, you need to carry out UPV test for uniformity, then your corrosion, and then your this chemical analysis for maybe what is the cause of corrosion, to know it is carbonation or it is chloride ingress. And cracks also, propagation of type of the pattern of the cracks may be required sometimes, but that is a more visual thing than to be done. So condition assessment, fine, okay, you are based on that, but then stability part is again related to your design also, because what are the for what purpose you are carrying out, it should be understood. Like, it is repair rehabilitation only, fine, but it is for retrofitting, then I think you need to carry out the complete analysis also. So there, I think you need to know the your this. Sometimes you need to find out your this like reinforcement bar also, which I have forgotten to mention in my presentation. You may be having the ferro scanner, or you may be having your other things. You know the your what is the bar diameter, what is the cover to concrete. The carbonation, again, important. Cover is very important there also. So carbonation, you find out, and cover also. So then a cover to concrete also, and then sometimes spacing is required. We did wall building, as I said, there was no design. These details were available, like your drawing was not available. They wanted to construct 7-story, because in Chandigarh there is that building was in that grade, which is in the 7-story, because of the zoning and planning, etc. of Chandigarh. So they were sure that it is a 7-story building, that they were not having any data, any drawing. So we carried out their foundation, we got it excavated, we took a core from that particular this thing, and found out the core was, we took a core of 800 mm. So depth, we knew the depth of that this raft foundation. Then we carried out their all the test for the like strength test for the column beams, and found out what is the concrete strength, how much is the bars are there, number of bars, spacing of bars. So every data we go to the designer, and he designed the things basically. So that is what I say, that your purpose, your this thing, condition assessment, repair, rehabilitation, or retrofitting, it will define your this thing. But basic test you have to carry out this much only.
Thank you very much, sir.
Yeah.
So how can we validate the data obtained by a sensor, sir? Or how well can we rely on the data given by a sensor?
You have to plot basically your this thing. So data acquisition system, if you have to strains, and then that data, and you may use it like if you are using for what purpose. I think your question is only to say get that particular information, or maybe to use it for future prediction also. So then you have to use some modeling purpose. Maybe you use ANN modeling, or use statistical analysis, regression analysis. That particular data you have to use. But I have not understood your question. For what purpose you wanted to use that data? That should be important.
If you're cross-checking the deflection of something, so how well can we rely on that particular data?
If we
Because
are
actually the input has to be perfect, right? In order to get
yes.
so how
If you suppose you are getting, you have put your strain gauges and all that. So deflection, how deflection you will measure?
pardon, sir?
How you will measure the deflection of a beam?
Then actually, with respect to a sensor, that's what I want. Of course, we can use a strain gauge.
Yeah.
So
you are using the strain gauges. So strain gauges, yes, you, because we if you are say carrying out your in your say lab, etc. Some you are like some testing maybe. So you have in that particular system, you basically you have the data acquisition system. So it is recording your, it is already having the software. So whatever the data you are getting, your this thing, so it is recording that, and that data basically from there you have to see in real time world, okay, what is happening over the period of time, 1 hour, 2 hour, 3 hour, like that, okay, whatever you are using. So over the period of time, how it is happening. We measured one अगर कहेंगे तो we used a very sort of a method like your this we use this dumpy level. Basically we use in the one particular building, we have used this leveling method to find out the deflection in the beam basically. But sensors, if you installed all those sensors already, the strain gauges are there, so you fix it with your data acquisition system, whatever you are getting, and that will give you that sort of a thing. Yes.
So with this, I would like to thank to Sanjay Sharma sir. Sir, you have given it not a brief walkthrough. You have given a very thorough walkthrough to the structural health monitoring, starting from the tests to the AI information you have given us, and machine learning theories you have given to us. Thank you so much, sir. And we have been very followers of your NCTL videos, lab videos. Still, we are encouraging our students to watch your NCTL videos.
Okay.
And we are very, yes, sir. We are very honored to have you here, sir. Thank you so much for joining us, sir.
Okay, thank you, and maybe I will got one match, so we will interact more in this thing. So thank you very much.
Sure, sir. Thank you, sir. Thank you so much, sir.
Right. I'm leaving.
I request all the participants to see the chat box for your feedback link. Kindly fill the feedback. It is not going to be longer in the chat box. The responses will be closed soon.